Good evening to all. Today cover the point on semiconductors. It is a very important topic for both finals and pre-final exam. Nearly one question will come in SAQs, and one bit is asked in regularly for all papers in the place of VSAQs. That means VSAQ is one question, SAQ is one question. Total 6 marks weightage as per final exam point of view. And it is very easy to present the answers from this topic. Because the questions are very limited and answer is very simple and there is no complex diagrams. And the presentation also very easy to write those sentences. And in that aspect, it is very easy to present the answers properly in final exam. One of the topic is semiconductors. And coming to the pre-final exam, because the limited chapters, there is a possibility of questions will come multiple from this chapter, because you are benefited in a final exam in this point of view. Because in a final exam, out of total syllabus, only one question will come. But comes to the pre-final exams, due to this syllabus limitation, from this portion, the question number will be more. We are easily presenting the answers because they are all are very important in final exam point of view. That one I let them know and try to follow those things and take the support of this class what I am presenting on the board. Whenever you learn the topic, take the support of this. That will help you to understand the points clearly and very easily to present the answers. Okay, I'll start that one now. Now, I'll start the SAQ. Important topic, SAQs. From the topic semiconductors. Semiconductor. Topic semiconductors. Okay, now one of the question I'll attempt now. Now how the battery is connected to the diode. How the battery is connected to the diode and explain those biasings. Here this is the symbol for the diode. It contains two terminals. One is positive, other one is negative. Positive denoted by P, negative represented by N. Where the long lead is present, that is positive. Where the short lead is present, that is negative. And it is an applied potential. This positive is also called the anode and the negative is named as the cathode. This is the way to show the PN junction diode in diagrammatic form. Okay now, the question is how the battery is connected to a junction diode in a forward bias and reverse bias. The question is like this. How? The question is how the battery is connected to the diode. This is the question. How the battery is connected to the diode. Already just now I told you this is the symbol for the diode first thing. The diode is represented by triangle. At the end one vertical line we are showing. Where this is the line, one side is called the anode, other side is called the cathode. Separately named as those. A stands for anode and K stands for cathode. Cathode. Anode represented by positive symbol, cathode represented by negative symbol. Now the diode has one junction. That reason the nature of biasing we are applied two ways. One kind of biasing is called forward biasing. How many ways you are connected? 2 ways. One is called forward. Second one is called reverse. How the battery is connected to the diode? How you are connected? 2 ways you are connected. One is called the forward, other one is called the reverse. What is the meaning of the forward? Forward is, this is the symbol, separately I am showing now. This is the symbol you know already, is nothing but battery represented by V. The battery has 2 terminals. One is a long terminal, other one is short terminal. Long terminal indicates positive, short terminal indicates negative. In case of the first way, the battery connection with respect to the diode is, I am showing separately this one now. The first case, you draw the diode, what symbol I am showing here. One side is positive, other side is negative. Now the way of connection is like this. What it represents now, positive is connected to the positive terminal of the diode, negative is connected to the negative of the terminal of the diode. That is called forward bias. Forward bias. Forward bias. It is one of the way to give the connection to the diode. It is one of the way to give the connection to the diode. Enough. That answer is enough. Positive terminal of the battery connected to the positive terminal of the diode. Negative terminal of the battery connected to the negative terminal of the diode is called forward bias. The name is clear, reverse. Reverse opposite now. What is the second one now? Reverse bias. That one also I am showing now. You consider the diode like this as it is. What I am showing earlier. It contains 2 terminals, positive and negative. Reverse the battery. That means what we have to reverse now? Positive is replaced by negative and the negative replaced by positive. We observe now. This kind of connection is called reverse bias. No need to write any more above these points. These points enough. What is this way of connection now? Reverse. Also called the reverse bias. How it is called the reverse bias? Negative of the battery connected to the positive terminal of the diode. Positive of the battery connected to the negative terminal of the diode is called reverse bias. As per the question, how many ways to connect the battery to the diode? 2 ways to connect the battery. One is in the form of forward bias, other one in terms of reverse bias. What is forward bias? Positive terminal of the battery connected to the positive of the diode. Negative terminal of the diode of the battery connected to the negative terminal is called forward bias. Second one is called reverse. What is the reverse? This supply is reversed, or the applied voltage is reversed. What way? Negative is connected to the positive and a positive is connected to the negative. That indicates reverse bias. Just by presenting these points, we are scoring 4 marks in exam. Next question now. Now based on this diode, we are observing the different applications. That one I try to cover those points now. Now the question is, how the semiconductor diode, second question, how the semiconductor diode, how the semiconductor diode is used as off wave rectifier. Off wave rectifier. How the semiconductor diode used as off wave rectifier. Very, very interesting and a very simple answer. Okay now? Now here, first thing is you draw the diagram. Because in physics, the diagrams are very important. Whatever the question will come in exam, the first step is to draw the diagram. Because without writing the content or without writing the answer, at least the diagram you drawn properly, you are scoring some of the marks in exam. From the total marks, you are getting some of the marks only for the diagram. In that aspect, the diagram play very, very important to gain the marks in exam other than 0 is always useful. That will score your marks every time and you are getting good marks. Even any mistake happening in a theoretical presentation of the answer, at least the diagram is correct. You are getting some of the marks. Okay now? Now here, this is the way to show the of a rectifier. I'll tell you one by one now. It is called AC voltage or AC supply. AC voltage or AC supply. The symbols I am showing separately. This is the way to show the AC supply. It is called AC voltage. AC voltage. Separately I am showing. No need to draw it separately, but the clarity purpose I am showing here only. Okay now? Now this is a part is named as, first one requirement is supply. And second one is transformer. This is called transformer. This one is called what? Diode. And the last one is called load. L stands for load. R stands for resistor. Load resistor. That means to construct the of a rectifier, the required parts are, one is AC voltage, second one transformer, third one diode, fourth one load. Once these are present, then possible to construct the of a rectifier. Okay now? That is the diagram for this of a rectifier. What is an of a rectifier? First I define now here. The definition of a rectifier, short form I am showing here now, HWR. Okay now? A circuit. What is circuit? Just now what I am showing on the board. A circuit which rectifies. Because the name itself is rectifier. A circuit which rectifies. A circuit which rectifies. Here how much is rectified now? The name is very clearly mentioned, off. Rectifies off. Rectifies off. Of the input. Input is what here? AC voltage. Off of the AC voltage. Off of the AC voltage is called of a rectifier. That means the given one is AC. From the what you are given, from that off is removed. That is called of a rectifier. Of a rectifier. Okay now? Come to the diagram now. Simple way I describe those. What are requirements now? One is transformer is required. Requirements are transformer. Second one is what? One diode is required, because you mentioned clearly one, because you are comparing later with another application of the diode. Only one diode is required. Third one is what now? Load resistor. That is called RL. Load resistor. These are the basic requirement to construct the of a rectifier. Of a rectifier needs one transformer, one diode, one load resistor. These are the requirements of the of a rectifier. What is the definition of a rectifier? By the given AC voltage, half of the wave is removed, half of the wave is rectified, half of the wave is eliminated. That is called of a rectifier. Of a rectifier. Okay, na? These are the points. Now I move to the operation, how it will works. To obtain the half of the output at other side of the rectifier, how it will works. That one I tell you now. Okay, na? Working now. It is AC. So next step is what? Working. Working. See now in the working process, what you are applied now? AC we are applied. The AC wave is coming like this. The AC wave comes like this. Now one is along the x-axis is time, y-axis is the voltage, because the voltage is the term I'm using there, that reason. This is it is called the alternating voltage. AC means what? Alternating voltage. Because in the topic of AC circuits, you learn the way how the AC waveform generated by the AC sources. Now come to the point now. It contains positive, negative, positive, negative, positive, negative. One is above the x-axis, other one is below the x-axis. You know the above the x-axis all quantities are positive. Below the x-axis all quantities are negative. The same thing is applicable for the wave also. One is a positive, other one equal and opposite, negative. Again positive, equal and opposite, negative. Positive and negative. This is the waveform passing through the diode now. This is the waveform passing through the diode. Now the diode already told you how many terminals it has. 2 terminals. One is positive, other one negative. See now how the diode should work. I'll explain that one now with the help of the diagram. This is the one interval. This is another interval. One more interval. Like this you should continue number of intervals. Okay now again you take the time and it is the voltage. What's the difference of these two? It is the AC input VI. It is the output we are observed now. Output means after rectified we are observed across the load resistor. That means that value represented by V0 or the V output. Then how it will work now? This is a positive. This positive reached the diode now. That means the given one is positive, a voltage is positive, diode terminal is positive, both are positive, then diode is in forward bias. That means AC input positive, diode terminal is positive, both are positive. Then it is forward bias. Then it is what happening? Forward bias. Whenever the diode is in forward bias, it is in on. Now it is in conduction. Whenever it is on, the waveform passing through this. Whenever it is positive and positive forward bias, the waveform passing through this. Once waveform passing through this, whatever you are given, same thing is coming now. Whatever you are applied, same thing will come. On which side? Positive side, same interval. Because total time T, it is T1, T2, T3, T4, T5, etc. we are considered. Same interval of this, positive will come. Go for a second case now. This is the part. What is that part now? I am writing here now. The second case. The second case is what? AC input is negative. This part is negative. That reaches here now. Now the diode still positive and negative. Now the negative is connected to positive. Earlier I told you. Negative to positive means what? Reverse bias. AC input is negative. Diode terminal is positive. AC input is negative. AC input is negative. Diode terminal is positive. AC input is negative. Diode terminal is positive. Whenever it is a negative and it is a positive, then what kind of biasing it is? Reverse biasing. The nature of biasing is a reverse bias. Once it is a reverse bias, then what happened? The waveform not passing through this. Reverse bias, the waveform not passing through this. Output is not present. That reason it is 0. You can go to the positive and positive, repeated. Negative to positive, no waveform. Again positive to positive, repeated. Negative to positive, no waveform. That means what is observed? We are observing the positive only present, negative removed. Positive is present, negative eliminated. Positive is present, negative eliminated. That indicates what? From the applied AC, half of the wave is removed. What is the half? Negative, negative, negative is removed. That is the functioning of a rectifier. That is the functioning of a rectifier. of a rectifier. Here one important one parameter is there, that is called efficiency. Okay, now only half of the wave is present. Next one, only one parameter we have, that is called efficiency, represented by neta. It is termed as neta efficiency. Efficiency. The value of neta is around 40.6%. Some books are 40 point, also they are given like that. That is how much it is, 0.406 load resistor divided by RF plus RL, or 40.6%. RF means what? Diode forward bias resistance. Diode forward resistance. Diode forward resistance. These are the points I have to present the answer. Finally, I conclude now. Of a rectifier represented by the diagrammatically like this. AC is voltage required, transformer, one diode, load resistor. Now the AC input we are applied now. Once it is positive, diode is positive, then only output is present. If the input is negative, diode is positive, then output not present. Earlier I am showing that in diagrammatically. At this time, only half of the wave is eliminated, remaining is present at the output side. Half eliminated is the basic property of a rectifier. That one is shown with the help of the diode. What is the efficiency of the rectifier? 0.406 RL divided by RF plus RL. Divided by RF plus RL. RF is called the forward resistance of the diode. Close it. Now we are extending this concept in another application of the diode, that is called full wave rectifier. How the diode is used as full wave rectifier. Next one now. Next question. How? Next one. How the diode used as full wave rectifier. Full wave rectifier. It is also very simple. How the diode used as a full wave rectifier. Okay, na? Now for this purpose, first step is what? To draw the diagram.